Hi guys, hello everyone. Myself I am Rahesh Cham. Now let us discuss about the subject is data structure. What is stock operation and stock push and operation, pop operation, overflow and underflow, application of stock. What is stock? Stock is a linear data structure in which the insertion of a new element and removal of an existing element takes place at the same end represented as the top of the stock. LIFO, last in first out. This is a staggered state that the element that is inserted last will come out first. You can take a file of the plate kept on top of each other as a real life example. The plate which we put last is the one of the top, and since we can remove the plate that is at the top, we can say that the that has put last comes out first. The following are the some common operations implemented on the stock: push, pop, is empty, is full, is peak, is display. Push operation. The push operation in a stock involves adding an element to the top of the stock. Check if the stock is full before pushing an element onto the stock. It is important to check if the stock has reached its maximum capacity. If the stock is implemented using a fixed size array, pushing an element when the stock is full could result in a stock overflow. This check ensures that the stock does not exceed its predefined size. Increment the top pointer. The top of the stock is a pointer or index that keeps track of the current position in stock. When pushing elements, the top pointer is incremented to move to the next available position. Add the element to the top. Once the top pointer has been adjusted, the new element is placed at the location indicated by the updated top pointer. This effectively adds the element to the top of the stock. Syntax: void push into stock into star top into value into maximum size open power bracket. If star top equal maximum size minus 1 open power bracket, printf stock overflow next line close the power bracket, else open power bracket star top plus increment stock star top equal value, printf percent d push on the stock next line value close the power bracket, close the power bracket. Pop operation. The pop operation in a stock involves removing the element from the top of the stock. Check if the stock is empty before attempting to pop an element from the stock. It's important to check if the stock is empty. If the stock is empty and a pop operation is attempted, it could result in an error known as stock underflow. This check ensures that there is an element to pop from the stock. Retrieve the element at the top. If the stock is not empty, the element at the top of the stock is retrieved. This is the element that will be removed. Decrement the top pointer. After retrieving the element, the top pointer is decrement to indicate that the top of the stock has moved down. Syntax: int pop into stack into star top open power bracket. If star top equal minus 1 open power bracket, printf stock underflow next line return minus 1 closer else closer power bracket else open power bracket. Int pop value equals stock start top increment, printf percent d popped from the stock slash n next line popped value, return popped value, closer power bracket, closer power bracket. Overflow and underflow. Overflow definition: overflow occurs when an attempt is made to push an element onto the stock that is already at its maximum capacity. Consequence: if overflow is not handled properly, it can be lead to data corruption or program crashes. Underflow definition: underflow occurs when an attempt is made up to the pop an element from the empty stock. Consequence: similar to overflow, if underflow is not handled properly, it can be lead to error and unaccepted behavior in a program. It is crucial to check for underflow before attempting to push pop an element from the stack. Display operation. Display operation in a stock involves showing or printing the element of the stock without modifying its contents. This operation is useful for debugging, testing, or simply observing the current state of the stock. Check if the stock is empty. Before attempting to display the element of the stock, it's a good practice to check if the stock is empty. If the stock is empty, there may be nothing to display, and attempting to display an element empty stock might lead to confusion or unnecessarily output. Iterate through the elements. If the stock is not empty, iterate through the element of the stock starting from the top and moving towards the bottom. If it is implemented as an array, display each element in the order it has added to the stock. Print or show the element. Print or otherwise show each element of the stock. This can be done in a loop or recursion, depending on the implementation. Syntax. Why display into stock into top open power bracket. If top equal -1 open power bracket printf stock is empty next line close power bracket else open power bracket printf stock element for int I is equal to top I greater than equal to 0 I increment printf %d stock I close power bracket printf next line close power bracket is empty operation. Definition. The is empty operation check if a stack has no element, meaning if it is empty. Use case. This operation is typically used before attempting to perform a pop operation. If the stack is empty and pop operation is attempted, it could result in an error called stack underflow. Syntax. Int is empty in top open power bracket. Return top equal -1 close power bracket. Useful operation. Definition. The useful operation check if a stack has reached its maximum capacity, meaning it is full. Use case. This operation is commonly used before attempting to perform a push operation. If stack is full and a push operation is attempted, it could result in an error called a stack overflow. Syntax. Int is full. Int top int max size. Open power bracket. Return top equal max size -1. Close the power bracket. Peak operation. Definition. The peak operation, also known as top operation, returns the element at the top of the stock without removing it. Stock. Syntax. Int peak into stock. Int top open power bracket. If top not equal -1 open power bracket, return stock top. Close power bracket else open power bracket. Applications of stock. Infix to postfix pre-expression, prefix conversion, radar under features of the many places like editor, Photoshop, forward and backward features in web browser, used in the many algorithms like Tower of Infinity, tree and transversal, stock span problems and Instagram problems. Backtracing is one of the algorithm designing techniques. Some examples of the backtracing are the night tour problems, NQ problems. Find your way through a max and game like chess or cheesers. In all these problems, we divide into some ways. If that way is not efficient, we come back to the previous state and go into the some other path. To get back from a current state, we need to store the previous state from the purpose. We need to a stock in a graph algorithms like topologicals, sorting and strongly connected components. Thank you.